Now, in this video, we're going to answer the following question. Using a sketch, find the area of the finite region or regions between y equal to x plus 1 multiplied by x minus 4 and the x-axis. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. A definite integral is the value of the signed area between a function's curve and the x-axis over a specific interval. It evaluates to a single value that can be either positive or negative, depending on whether the area lies above or below the x-axis. Answering this question is a 5-step process. First, by sketching the graph of the function, we can identify the region that we are calculating the area of. Then, we need to expand the brackets and integrate each term separately, using the power rule for integration, before substituting the limits and simplifying to find a value for the area. Equating x plus 1 and x minus 4 to 0, we can find the points of intersection with the x-axis for the function, and x is therefore equal to -1 and 4. These points also represent the limits between which we're going to integrate. The equation is a positive quadratic function, which means that it's a U-shaped curve called a parabola, with a vertex at the bottom, representing the minimal value of the function. So, drawing a pair of axes, with points marked at -1 and 4 on the x-axis, we can sketch the curve and highlight the area we're going to calculate. We're going to calculate the signed area for this shaded region below the x-axis. The area will have a negative value for that reason. To integrate the function, x plus 1 multiplied by x minus 4 between the limits 4 and -1 with respect to x, we first need to expand both brackets, which gives us the integral of x squared minus 3x minus 4, keeping the same limits. we need to integrate each term separately using the power rule for integration. The rule states that for any real number n, with the exception of 1, the integral of x to the power of n is equal to x to the power of n plus 1 divided by n plus 1. In other words, we increase the exponent by 1 and divide by the new exponent. So integrating x squared gives us x cubed divided by 3. Integrating minus 3 gives us minus 3x squared divided by 2. And integrating minus 4 gives us minus 4x. We enclose this expression between a pair of square brackets, with the limits 4 and minus 1. Now, we need to substitute both limits for the variable x, and then subtract. First, we substitute 4 for x, giving us 4 cubed divided by 3 minus 3 multiplied by 4 squared divided by 2 minus 4 multiplied by 4. Then we substitute minus 1 for x, giving us minus 1 cubed divided by 3 minus 3 multiplied by minus 1 squared divided by 2 minus 4 multiplied by minus 1. We need to evaluate and subtract these expressions. Simplifying both brackets, we get minus 56 thirds minus 13 sixths, which gives us the answer minus 125 sixths, or minus 20 and 5 sixths. The minus sign indicates that this value represents an area below the x-axis. So the absolute value for the area is equal to 20 and 5 sixths. So the area of the region between the curve and the x-axis, and the answer to this question, is 20 and 5 sixths. If you found this video useful, please consider leaving a like, a comment, and subscribing to our channel. Thank you.